Hi, this is a supplementary math lesson for advanced math, set 83, lesson 83 in your textbooks, simple probability. The section is pretty easy read, so go ahead and read that over. I just wanted to hit a couple points real quick. We really only have one equation for determining the probability, and it's that same convention that they used in the crash course statistics video. We're going to use the capital P, the probability of an outcome, H in parentheses. Whatever's inside the parentheses is called the outcome. So the probability of an outcome H is the number of outcomes that are H divided by the total number of outcomes possible. And so beyond that, we don't really have any equations like we did as far as combinations and permutations and distinguishable permutations, and we even have those functions in our calculator. With simple probability, it comes down to basically counting out manually, figuring out, okay, what are the possible total outcomes. Well, we have to use logic and reasoning and kind of a logical approach to the scenario, and then go ahead and count the number of outcomes that meet our criterion. The book has two methods for doing that. An example 83.1 on page 500. They have using a tabular form to come up with what they call the sample space. The sample space is the theoretical, theoretical probability of an outcome. And so we list all of those possible outcomes. They call those events. So the theoretical outcomes would be an event within that sample space. Okay, so they have a tabular way of coming up with that. You can look for that. That was with a roll of the dice. For coin flipping or some other scenario, they have this tree diagram to do that. So we kind of have to physically go through and figure out, okay, what are the total number of outcomes possible, and then go through that total possible outcomes and see how many of them meet our criteria. And that's what we did our statistics project. The first thing we had to go through is figure out, okay, theoretically, with rolling 3 dice and adding them up together, how many possible outcomes of those 3 dice are possible. You know, if we considered we could actually tell the difference between die 1, 2, and 3, okay? And so that's what we did, and it was, you know, you got to go through a step. In that case, we had to go through 216, list the 216 possible outcomes, that they could be. And then, if we were wanting to know the probability of a certain event happening, say a double's coming up, we go through that whole list. We go through our whole table here, or we would go through our whole diagram, tree diagram here, and count up the number of times that a particular outcome is valid or is true. And so there's a lot of more physical work involved with. So the concept of probability is a lot easier to understand, but there's a lot more physical work involved. It's not hard work, it's just time consuming and monotonous, I would say. With that, the other thing I just wanted to hit on quick, so our statistics video on probability hit on the concept, which I'm glad it did, because it doesn't hit it in the book, of the concept of empirical probability and theoretical probability. And that's kind of what I was wanting to get at. And we'll discuss this more once these statistics projects all come in. I've got a couple of them in right now. And so I really wanted you to see, okay, when we call theoretical probability, and that's what we did when we went through and determined our sample space, okay, and we kind of used, I kind of used a tabular method. It was actually kind of a cross between these two. I took a more regimented tabular approach to determining that sample space. So we found out, you know, okay, theoretically, okay, these are the 216 possible outcomes when we roll 3 dice. Now, empirically, and anytime you hear the word empirical, that means through experiment. We're gathering real life data, real life actual events. So we say, fine, knowing that, let's roll our dice 3 times, okay, empirical probability, and see if they match, okay? And often, okay, we're saying in real life, our theoretical probability, okay, should be close to our empirical probability, or what we say in real life often is the empirical probability should mirror what the theoretical probability says it should be. Okay, now often in the case, it does not. It does not do it, but the one thing that the statistics project was supposed to kind of drill home to you is the more and the more and the more we do that, okay, when we rolled our dice a few number of times, what was it, like 28, okay, generally that's probably not too close to the theoretical probabilities that we see. When we rolled it 100 times, it should be getting closer. When we rolled it 216 times, now technically, if we rolled the dice 216 times, it should come up exactly what our theoretical probability says it should be. We should roll one of those combinations, one of those events each time. Does that happen? Not exactly. Okay, why? Because it's a random event. But if we rolled it 400 times, if we rolled it 500 times, if we rolled it 5,000 times, okay, we should be getting closer and closer to that normal distribution curve for our theoretical probability, okay? And so when we do a small sample, empirical data, it's more likely to have error when compared to what our theoretical probability should be. The larger the sample size, the more and more samples we have, it should get closer and closer and closer to our theoretical probability. And the more and the more and the more we do, also what happens is the next roll that I make has less bearing on the overall calculation of the mean and the variance, the standard deviation. Because when I roll the dice 5,000 times, okay, that 5,001th roll has a smaller bearing on the population as a whole than when I roll the dice 10 times and then my 11th roll. My 11th roll has a significant influence on what the mean, the variance, and the standard deviation would be with a sample size of 11 compared to 5,001. Okay, so that was one of the things I wanted to hit home. We'll be hitting on those major points too when all the projects come in. So we have this lesson today. You have one more textbook lesson next week, and we'll have 3 more videos for you to watch, and we'll wrap up advanced math for this year. I'm planning, I would like to get that video done for next week's lesson and those 3 crash course videos sent out to you sometime this weekend, maybe beginning of next week. So if you want to go ahead and get through them and get through the class and be done a little bit early, you can do that, especially if you have work in other classes to finish up for the year. So the big thing is, for a couple of you need to get that statistics projects in. I anticipate those will be coming in Thursday. So that's it for the lesson today. We'll be seeing you later. Looks like it's going to be a great weekend, so have a great weekend. Bye for now.